So for this problem, we're going to start by trying to find the speed of the wheel. So this is a Doppler effect problem, but a double Doppler effect. So first, the submarine sends a first wave with frequency f towards the wheel. This wave, when it is perceived differently by the wheel because of the Doppler effect. So it's perceived with a frequency f prime when it reaches the wheel, and it will bounce back on the object and go back towards the submarine. When it gets back to the submarine, it's perceived again with a different frequency because again of a second Doppler effect, and the new frequency, we're going to call it f prime prime. So we're going to use this formula for the Doppler effect. So the speed of the object VO and the speed of the source VS are always going to remain positive in this problem because both objects are moving towards each other. So the first equation is going to be this one. So F prime is going to be the speed of sound plus the speed of the observer. Here the observer for the first wave that's sent from the submarine towards the wheel. So the first observer is the wheel. So it has a speed v1. Then we're gonna have v minus the speed of the source, and here the source is the submarine with a speed v2. And that towards the initial frequency, which is f. Then for the second Doppler effect, we have f prime prime is equal to the speed of sound again, plus the speed of the observer, but for the second wave that travels from the wheel towards the submarine, the observer becomes the submarine, so plus v2 this time. Then we divide by v minus the speed of the source, which is v1. And now the initial frequency is the frequency that was perceived by the wheel, so f prime. Then we're gonna put this equation into here, so we're gonna substitute for f prime. So f prime is v plus v1 over v minus v2 times f. So now we can plug in some numbers. So f prime prime is 10.6 kilohertz, and f is 10 kilohertz. Here the units don't matter because they cancel out each other. So the speed of sound v is 1500. The speed v2 is the speed of the submarine, so it's 10 meters per second. And we are looking for v1. Okay, so now we can find these two numbers here. So 10.6 is equal to 1510. We can switch, since these are two fractions that are multiplied, we can just switch the denominators. So here this one is going to be 1490 times 1500 plus v1, 1500 minus v1 times 10. We can put all the numbers on the other side, and so we divide by 10 and we multiply by 1490 and we divide by 1510. So here we can find this number, which is going to be 1.046. We can keep 4 significant figures, that's going to be fine for this problem. Okay, now the key step is to multiply both sides by the denominator here to cancel it. And now we get this simple equation which we can easily solve. So we get 1569 minus 1.46 V1 is equal to 1500 plus V1. We can send the 1.46 V1 on the other side and the 1500 here. So we get 69 is equal to 2.046 V1, and we can divide both sides by 2.046 to get V1. And we get that V1 is approximately 33.7 meters per second. So that's it for the first problem.